Week 2 is Pythagorean Theorem and its converse. Most of this is going to seem pretty familiar because we've actually been using Pythagorean Theorem all year so far. This is where your book finally kind of tells you how to do it and gives you a little bit more with it, but for the most part, this is not going to be new information. This is stuff we've already had, so keep that in mind as we're looking at it. Pythagorean Theorem itself, as you all know pretty well by now, is a squared plus b squared equals c squared. Where a and b, those are both the legs, and c is the hypotenuse. Remember, you can always tell which side's the hypotenuse kind of on two things. Best way, it's always across the right angle. And then second way, it's always going to be the longest side. So these next two, we're just going to do something we've done a lot of already. We're going to find the missing measure. So on the green triangle, we've got 5 and 12. Blue one, I've got 9 and 15. When we've done these, what we looked at first was always, what is it that we actually know? In the case of the green triangle, the 5 and 12 would both be the legs. So what I don't know is the c, and that's important. So I do 5 squared plus 12 squared equals c squared, and then I solve that. I'll give you a little time to do that. Square each part, so you get 25 plus 144 equals c squared. Add 25 and 144, you get 169 equals c squared. Then because you want c by itself, you'll take the square root. And the square root of 69 is 13. So that's our missing side. That's the hypotenuse. The one in blue is going to be a little bit different because on this one, you know what the hypotenuse is. You know c. What we don't know is one of the legs, and it never matters which one goes in for A or which one goes in for B, so you choose. I'm going to make it A is the 9 squared, plus I don't know B squared, but I do know C is 15 squared, and then I'm going to solve that. 9 squared gives me 81 plus B squared equals C squared, which would be 15 squared, 225. A little bit different here. I want to get B by itself, so to get rid of that 81, it's positive, so I'll subtract. So I've got 225 minus 81. So I get b squared equals 144. And just like the other one, to finish it, I'll take my square root. And the square root of 144 is 12. So that's the missing side on that one. So just a thing to keep in mind, look at it. Before you start doing any work, think about what is it that you know, what is it you're trying to find. Do you know both the legs and you're trying to find the hypotenuse like the first one, or do you know one leg and one hypotenuse and you know? Because that'll change how you set it up and how you work it out. The next part, it's something you can get by without knowing, but if you know them and you have them memorized, it can make some of these problems go a whole lot faster. They're called Pythagorean Triples, and there's a set of any 3 numbers that satisfy the Pythagorean Theorem. Most common one, and the one that I would suggest that you know pretty well, is 3, 4, 5. If you've got lengths 3, 4, and 5, it must be a right triangle. Next most common, 5, 12, 13, and yeah, maybe not as common, 8, 15, 17, and then 7, 24, 25. Another way these can be helpful, if I double all these numbers, like if I make that 6, 8, 10, that has to be right triangle. If I triple these original numbers and get 9, 12, 15, kind of like we saw in the last example, that's a right triangle. And that works with any of these. So if I had 10, 24, 26, must be a right triangle. And that's a faster way to figure it out. But if you didn't know, there are other ways to tell whether or not it is a right triangle. And that's the converse of the Pythagorean Theorem. If you got 3 lengths of the triangle, A, B, and C, and you plug them into this, A squared plus B squared equals C squared, and it works, as in they are equal, the triangle must be right. Now you're going to know which one goes in for C or which one you're going to try for C based on which one's biggest. The A and B, again, it doesn't matter which one's which. Your biggest side is what you plug in for C. If that's true, it's a right triangle. other options, and there's only going to be two other outcomes. If c squared is less than a squared plus b squared, then the triangle is acute. If c squared is less than a squared plus b squared, it's acute. And then opposite of that, if c squared is greater than a squared plus b squared, then the triangle is obtuse. And those are the only options you could have. They're either going to be equal, c squared could be smaller and it's acute, or c squared could be bigger and it's going to be obtuse. But it must be one of those three. So that's a test without actually seeing the triangle to tell which kind it is, just off the sides. You don't have to know the angles to answer this. So examples. We're going to determine whether each set of numbers can be the measures of the sides of a triangle. That's going to be new, but it's pretty easy. And then we're going to classify the triangle as right, obtuse, or acute. So first of all, we're going to figure out whether or not it can be a triangle. Once we know that, we'll figure out what type it is. So 12, 16, 20. To be a triangle, when you add the smaller two sides, they've got to be bigger than the third one. So on the first one, if I take 12 plus 16, that needs to be greater than 20. 12 plus 16, I get 28. That's greater than 20. So that checks out. So that's going to be a triangle. I can tell that. Now I want to figure out what kind it is. So I'm going to use Pythagorean Theorem. Figure out. When I do c squared, which is 20 squared, how does that compare, I'm going to leave a blank there, to 12 squared plus 16 squared? I want to know if they're equal or if one's bigger than the other. So 20 squared, you probably need to type most of these in. Gives me 400. Still don't know what goes in the blank. 12 squared gives me 144. Plus 16 squared gives me 256. And then I add 144 plus 256, and I get 400. That tells me that they are equal, so it's a right triangle, because they were equal. And that's what you're checking. So when you plug it in, how do they compare? Next one, 10, 11, 13. So first thing, see if it could be a triangle. If I do 10 plus 11 greater than 13, yeah, that's true. So it's a triangle. Next, see how it fits in the theorem. Biggest one's 13 squared, so I put it over here. Leave a blank. 10 squared plus 11 squared. 13 squared gives me 169. Still got my blank. 10 squared is 100. Plus 11 squared, 121. Now looking at that, obviously the right side is going to be bigger. So c squared is less than a squared plus b squared. That makes it acute. That's how you tell what type of triangle it is. And actually, that's it for this one. So your homework, which we do next time, is 1 through 27 odds, and then I also want you to do 38. And then there will be a quiz next time over the two sections you looked at today. Pretty short like normal. 3 to 4 questions over 8-1 and